purpose of this tutorial is to provide answers to the Chapter 6 review, so let's just do it. All right, CD is 20, BE is 9, that's half of the diagonal, and the measure of angle DAB is 50 degrees. Find the following measures. A is BD. Well, a BE is 9, and we know that the diagonals of a parallelogram bisect each other. DE must also be 9, so BD must be 18. AB is the opposite side of CD, and in parallelograms, opposite sides are congruent, so AB is 20. DE, as we've already said, because DB is bisected, DE must be 9. The measure of ABC, I'm looking for this angle. In parallelograms, consecutive angles must be supplementary. Since DAB is 50, ABC must be 130. Following around, BCD has to be congruent to DAB, so it has to be 50. And CDA has to be congruent to ABC. It has to be 130 degrees. Number 2, three vertices of parallelogram DEFG are -1, -3, 4, -1. This is E, this is F. G is -2, 1. And we would like to find the coordinates of D. This chart doesn't really go out far enough, it looks like, because notice it has to be DEFG, and so D is going to have to actually be, it looks like, somewhere over here. The easiest way for me to work this problem is to say, how did I get from F to E? Well, in order to get from F to E, I went left 1, 2, 3, 4, 5, and down 2. So to get from G to D, I'm going to do the same. I'm going to go left 5, 1, 2, 3, 4, 5. That actually puts me at -7. Down 2 is going to put me at -1. So the coordinates of D must be -7, -1. If I have this to do over again, I'll try to put a coordinate graph where you can actually plot the point. Understand again why you can't put D up here is because then you would have parallelogram GDFE, which is not the same as DEFG. All right, number 3. Notice I got my pictures are all sitting here, but I guess I'll get over it. PQRS is a parallelogram. We want to know each measure. PS, well, I know opposite sides of a parallelogram are congruent, so 7y plus 3 must be equal to 4y plus 15. Subtracting 4y, we get 3y plus 3 is equal to 15. Subtracting 3 from both sides, 3y is equal to 12. Y is equal to 4. If y is equal to 4, then PS is equal to 7 times 4 plus 3, which is equal to 31. QR better be the same thing because they're opposite sides. Just to make sure, 4 times 4 is 16. 16 plus 15 is also 31. The way I'm going to find the measure of angle P is I know that angle P and angle S must be supplementary because they're consecutive angles of a parallelogram. So 8x minus 7 plus 3x plus 22 equals 180 degrees. Combining like terms, 11x plus 15 is 180. Subtracting 15 from both sides, 11x is 165. Dividing both sides by 11, x equals 15. I didn't want to know x though, I wanted to know the measure of angle P. The measure of angle P is going to be 3 times 15 plus 22, which is 45 plus 22. Believe it or not, that is a 5. 45 plus 22, which is equal to 67 degrees. Once again, I understand that that angle looks obtuse, but we're going by the algebra. Apparently, when we tried to draw the parallelogram, we didn't do a very good job. We're going to take the properties of parallelograms, though, not the way they look. The measure of angle P is 67 degrees. Therefore, the measure of angle S must be 180 minus 67, which is 113. I'm going to try just to make sure that I did this right. 8 times 15 is equal to 120. 120 minus 7 is 113. Number 4, find x and y so that the quadrilateral is a parallelogram. Same as before, opposite sides are congruent, so 10x plus 11 is 8x plus 17. Subtracting 8x from both sides, 2x is 6, x is 3. Solving for y, 6y minus 30 equals y plus 15. So 5y is equal to 45. Y must be equal to 9. That didn't seem too tough. Number 5, A and B is what we need so that we have a parallelogram. Well, I know opposite angles of a parallelogram are congruent. So 8a plus 13 equals 12a minus 7. I'm going to subtract 8a from both sides, and I get 13 is equal to 4a minus 7. 20 equals 4a. A equals 5. So I've got A equals 5. Oops, that wasn't very bright, was it? A equals 5. And let's see if we can figure out what B is. If A is equal to 5, 12A minus 7 is 12 times 5 minus 7, which is 60 minus 7, which is 53. If the measure of angle K is 53 degrees, then the measure of angle J must be 180 minus 53. So the measure of angle J must be 127. But the measure of J is also 14b minus 27. So 14b minus 27 equals 127. Adding 27 to both sides, 14b is equal to 154. Dividing both sides by 14, b equals 11. So A is 5, B is 11. Number 6, determine if we have a parallelogram or not. A, hopefully we haven't fallen for this one again. I have one set of opposite sides that's congruent, the other side is parallel. This could be a parallelogram, but it could just as easily be an isosceles trapezoid. Right? Because in an isosceles trapezoid has one set of parallel sides and the legs are congruent. So we don't know if it's a parallelogram or not. If it's a trapezoid, it is certainly not a parallelogram. Okay. For B, I have the same set of opposite sides that are congruent and parallel, and the answer is yes. That is enough information. We have a theorem that tells us so. C is actually a little tiny bit trickier. We have parallel lines. Well, if I have parallel lines, x, y, and w, z, I know that z and y are same side interior angles, so they are supplementary. I'm just going to put the two little red marks here. I know this is supplementary. Y is supplementary to z. By the same argument, w is supplementary to x. Now I have two angles that are supplementary to the same or congruent angles, in this place congruent angles. If I have two angles that are both supplementary to congruent angles, those two angles have to be congruent. Now I have opposite sides of a quadrilateral, opposite angles of a quadrilateral that are congruent. Therefore, the answer is yes, it must be a parallelogram because opposite angles are congruent. Number 7, show a quadrilateral with vertices A, -3, 6, B, -5, 0, C, 4, 3, and D 2, -3 is a parallelogram. Okay. It will be a parallelogram, but it won't be a parallelogram as numbered here or lettered here. A, B, C, D certainly won't give us a parallelogram, but I believe we will find B, A, C, D will. Okay. There are a lot of different ways to prove that something is a parallelogram. If I'm really doing this on my own, trying to do it as quickly as possible, the easiest way for me to prove that a figure is a parallelogram is just to show that both sets of opposite sides are parallel. Okay. So my first question may be, what is the slope of AB? Well, let's see, I'm going from -5, 0 up to -3, 6. So my y values, I'm going up. My rise is 1, 2, 3, 4, 5, 6. And my run goes from -5 to -3. I have a rise of 6 and a run of 2. The slope of AB is 3. What is the slope of DC or CD? The slope of CD, well, I'm rising 1, 2, 3, 4, 5, 6, running 2. The slope of CD is 3. So I know I at least have a trapezoid. One set of parallel sides is not enough. I have to show another set of parallel sides. So what is the slope of AC? Well, to go from A to C, I'm going to have to go down 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7. So the slope of AC is -3/7. The slope of BD is down 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. The slope of BD is -3/7. Because opposite sides are parallel, I do have a parallelogram. Also, I know beyond a shadow of a doubt this is not a rhombus, because if it were a rhombus, if the slope of AB was 3, the slope of AC would have had to have been the opposite reciprocal of 3, which is -1/3. Number 8, this is a rectangle, QRST. RT, the big diagonal, is 55. QR is 45. Okay. Find each length. PR. Well, PR is going to have to be 55 divided by 2 because a rectangle is a parallelogram. And so I'm just going to leave my answer as that, 55 halves. QS has to have, because it's a rectangle, the diagonals are congruent. If RT is 55, QS also has to be 55. RS is going to be a little harder because it's a rectangle. I have a right angle. Okay, and since I have a right angle, I have a right triangle, and I'm trying to find this side B. And so what I'm going to have to do is use Pythagorean theorem. 45 squared plus b squared is equal to 55 squared. And as sad as it is, I'm actually going to have to do the long multiplication. So 45 squared is 1225 plus b squared is equal to oh my gosh, let's try that again. 55 times 55, 5 times 5 is 25, gives me a 2, gives me 275. I knew something wasn't right there. And 275, 5, 2. Sometimes it's the easier things that manage to trip us up. And this one's 3025. Okay, so 1225. By the way, I need to go back and do this one, I'm sure, also. 225. Hopefully y'all have looked at that and said, what on earth has he done? This should be an 8 And so that should be 2025. So 2025 plus b squared is 3025. B squared is equal to 1000. So b is equal to the positive square root of 1000, which if we were to simplify this out, would be 100 times 10, so it would be 10 times the square root of 10. I'll bet watching me you never thought I would get there. Okay, so RS is 10 root 10, and QP has to be half of 55, so it's going to be 55 halves. WXYZ is a rhombus. Find each missing measure. We want to know what is YZ. Well, if it's a rhombus, all four sides are congruent. I know that WX is congruent to XY. So 9a minus 10 equals 5a plus 6. Subtracting 5a, I get 4a. Adding 10, I get 16. Dividing through by 4, a equals 4. If a equals 4, 9 times 4 is 36, minus 10 is 26. By the way, 5 times 4 is 20, plus 6 is 26. YZ is 26. The measure of WXZ, by the way, let me clear this out and do it again. It's 26. The measure of WXZ, which is this angle, and the measure of XYZ, which is this big angle, if the measure of YVZ equals 7b plus 27, and the measure of WYZ, this little piece here, equals 3b plus 7. Okay, they're putting a little trick on us here, but the thing we know about rhombuses, or rhombi as I like to call them, is the fact that their diagonals bisect each other. So the measure of YVZ, the measure of this angle, has to be 90 degrees. So I'm going to be able to say 2b plus 27 is equal to 90. Subtract 7b plus 27 is equal to 90. 7b must be equal to 63. B must be equal to 9. Okay. If b is equal to 9, 3 times 9 plus 7 is 27 plus 7, which is 34. The measure of angle WYZ is 34. And so therefore, the measure of this big angle must be 34 times 2, which is 68. So the measure of angle, I'm sorry, we just wanted WYZ. And so if WYZ was 3b plus 7, my angle is going to be, oh, here we go, I'm sorry, again. I want to know WXZ, and I want to know XYZ. So I did want to know the big angle. The big angle has to be 34 times 2, which is 68. And then I wanted to know the measure of XYZ. I'd do that at XYZ. XYZ must, I'm going to get this right before it's over with here. XYZ is 68. WXZ is the one I'm looking for. I should draw this out, and I probably should actually work these out before I try them here. This is the angle that I'm looking for. What I know is if this angle is 68 degrees, the other angle must be 180 minus 68, which is 112. The diagonals of a rhombus bisect the angles. Half of 112 is 56 degrees, and so the measure of WXZ is 56. And if you can still do this problem after I just butchered it that badly, you're well on your way to doing well on this test. Number 10, determine if the conclusion is valid. AB is congruent to CD. BC is parallel to AD. Holy cow, hopefully by now you recognize that that could just as easily be an isosceles trapezoid as a parallelogram. Don't fall for that. The answer is no, that is not enough information. What could I do to make it be a parallelogram? Lots of different things. I could say that AB is parallel to CD. That would be enough. I also could have done instead BC is congruent to AD. That also would have been enough information to say that I have a parallelogram. Number 11, AC bisects BD. AC bisects BD. Is that enough to say that I have a rectangle? And the answer is no. That's not anywhere near enough information. AC bisects BD isn't even enough to say I've got a parallelogram. I would also need to say that BD bisects AC. That would give me a parallelogram, and then in order for it to be a rectangle, we would have to know that the diagonals were congruent, so we could put that AC is congruent to BD. Okay. I know you might have just said, hey, angle A, angle B, and angle C all need to be 90 degrees. That in itself probably would have been enough, but that's probably what they're not looking for here if they've given you something about the diagonals. All right, use the diagonals to determine whether a parallelogram is a rectangle, rhombus, or square. I've got W equals -4, -1. X is equal to -1, 3. Y is equal to 3, 0. And Z is equal to 0, -4. Okay, I already know that I have a parallelogram. I don't have to check anything as far as being a parallelogram. One of the things I might want to see in order to know if it's a rectangle is I might want to know is this angle 90 degrees? Because if that angle is 90 degrees, then all four of the angles have to be 90 degrees since I already know it's a parallelogram. How am I going to know if that angle is 90 degrees or not? I'm going to know whether or not the two lines are perpendicular by looking at their slope. Okay. So what is the slope of WZ? Well, let's see. To go from WZ, I go down 1, 2, 3, and over 1, 2, 3, 4. The slope of WZ is -3/4. What is the slope of ZY? Well, now I'm going to go up 1, 2, 3, 4, and over 1, 2, 3. So that slope is 4/3. Sure enough, those are opposite reciprocals, so I know that I have at least a rectangle. There are a couple different ways to know if this figure is going to be a rhombus, but what I believe I'm going to do to see if I can find out if it's a rhombus is just see if these two sides are congruent. Because if those two sides are congruent, all four sides are going to have to be congruent. So what is WZ? Notice that if I write just the letters WZ, I'm asking just for the distance between the point W and Z. I already found out that I can make a right triangle out of this. This leg is 3 and this leg is 4. That tells me that WZ must be 5. Okay? A 3, 4, 5 right triangle. If you don't believe that, go ahead and try the Pythagorean theorem, and if you do it correctly, you'll find out that it's 5. By the same token, if I look over here for what is ZY, I have one leg that's 3, one leg that's 4, a right triangle here. We will also find that ZY is equal to 5. Because they're both equal to 5, those two legs are congruent. Because it's a parallelogram, all four legs have to be congruent. This must be a square. Number 12, or 11b, excuse me. Let's see what we can find this time. I've got M at 0, 1. I've got N at 2, 6. I've got P at 4, 1. That's a P. And I've got Q at 2, negative 4. Okay. Here is my figure. I can pretty much guarantee you that this is not a square. Okay. It's a parallelogram. I can almost guarantee you already that it is not a rectangle. Okay, but let's just make sure. How can I tell if this thing is a rectangle or not? Well, let's look at the points. What is MN? What is the slope of MN? Well, to go from M to N, I had to go up 1, 2, 3, 4, 5, and over 1, 2. So the slope of MN is up 5 over 2. The slope of NP is equal to down 1, 2, 3, 4, 5 over 1, 2. So it's down 5 halves. Are those two numbers opposite reciprocals? No, they are not. I do not have a rectangle. If I don't have a rectangle, I don't have a square either. Okay, what about a rhombus? Well, if I look at my rectangle, this is 5 and this is 2. 25 plus 4 is 29. That's distance. We're going to find out that MN is the square root of 29. And we should able quickly find out, using this right triangle, that NP is also the square root of 29. If these two sides are congruent and it's a parallelogram, the opposite sides also have to be congruent. This figure is a rhombus. This time I've got that I have a rhombus. W, X, Y, Z is a rhombus. E, F, G, and H are midpoints. The measure of FEH is 90 degrees. Okay, I want to show that EFGH is a rectangle. Okay. I have been called away. I will begin number 12 on the second part, and I'll talk to you later.